What do you call, or what do you say when a merman marries a mermaid? They're married! Alright, today your frame looks like this. Cha. Alright, our key idea is order of operations. And the order of operations is about following the correct steps to evaluate an expression. Alright, if we didn't have the order of operations, we would all be evaluating expressions in different ways, getting different answers. So that's why we have the order of operations, is to make sure that we all follow the same steps. Alright, we are going to first look at that steps column and label our GERMDAS. Alright, so the G in GERMDAS stands for grouping symbols. And grouping symbols come in a lot of different ways. They can look like parentheses, like brackets, like the fancy brackets. I don't know what these are actually called. The ones that have like the little pointy thing. Absolute value lines, and that long division line where it actually is kind of like a fraction bar. Alright, if we go down to the next one, we have exponents and radicals. Exponents are when you have a number and there's a number above it. That's that. Exponents. And radicals, which look like this. Alright, and when you do exponents and radicals, you want to go from left to right. Alright, so if a radical comes before an exponent, you're actually going to do the radical first. Alright, even though it goes ER, it's always left to right. The next one we have is multiplication and division, or multiply and divide. And again, with multiply and divide, we want to go left to right. And the last one is to add and subtract. And this is also left to right. Alright, so we're going to go to our first example. That's going to be in the first column next to the steps. So we're on that first column next to steps. The example that we're going to do here is we're going to do the square root of 3 times 5 plus 5 times 2. That's square root sign of the radical going all the way across it. Okay, so GERMDAS, G is grouping symbols. Here we have parentheses, but remember that these parentheses, they just mean, whoa, I went back one, I didn't know that. That these grouping symbols, these parentheses, just mean multiplication. Okay, so just remember that means multiplication, so we don't actually have to treat them like grouping symbols here. Alright, we don't have any exponents. We do have a radical, but the radical goes over the entire thing, so we have to figure out the inside first before we can do the radical. Alright, we have multiplying and no dividing, so we got to do the multiplying first. So this is equal to the square root, and we do left to right. So first we have to do 3 times 5, which is 15, plus, since there's an adding in between, we can do 5 times 2 at the same time. 5 times 2 is 10. Alright, now we can do the adding. We can't do the radical yet because we have to take the radical of the whole inside. So 15 plus 10 is 25. In the square root of 25, we have to think what number times itself equals 25? Well, that's 5. So that is our final answer. Alright, we're going to go into that middle column. In that middle column, we have, this one's kind of long, so watch out. 4 minus 3 to the third power plus the opposite of negative 6 times 4. Alright, so we do have a grouping symbol here. The grouping symbol is this negative 6. Okay, and we actually do want to deal with that first because there's an opposite sign on the outside of it. Alright, so we're going to get, we're going to get, this is equal to 4 minus 3 to the third power plus the opposite of negative 6 is a positive 6 times 4. Alright, so that was the grouping symbol. There's no more grouping symbols. Now we have exponents or radicals, and we do have an exponent here, and that's 3 to the third power. That means that we're going to do 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Oops, 27. So this is equal to 4 minus 27 plus 6 times 4. Alright, are there any grouping symbols now? No. Are there any exponents or radicals? No. Is there multiplying and dividing? Yes, there is multiplying. So the next thing that we're going to do is do this multiplying part. So we have 4 minus 27, we keep what we're not touching, plus 6 times 4 is 24. Alright, so are there any grouping symbols now? No. Any exponents or radicals? No. Any multiplying or dividing? No. Any adding or subtracting? Yes. We want to do adding and subtracting from left to right. So we're going to want to do this 4 minus 27 first. Alright, instead of doing 4 minus 27 though, subtracting is adding the opposite. So I'm going to do 4 plus negative 27. When we add a positive and a negative, we subtract and keep the sign of the larger number. So 27 minus 4 is 23. Keep that sign of the larger number, which is negative, plus 24. Okay, now negative 23 plus 24, we get a positive 1. Okay? So whenever you do this, always go back and check, is there a grouping symbol now? Is there an exponent or radical? Is there multiplying and dividing? Is there adding and subtracting? Always start over no matter what step you're on. Alright, last column. Alright, watch carefully before you write this one down. We have 10 plus 5 squared times 2 over the absolute value of negative 6 times 2. Okay, write that down. Alright, so we have to decide if there's a grouping symbol. Here there's a couple grouping symbols. We have absolute value sign, but we also have that long division sign. Okay, so right here at the top, this we need to figure out, and this we need to figure out, so it's down to one number before we can actually start dividing it. Okay, so let's do the top first. Alright, we're going to leave the bottom. Not going to worry about it. I'm going to copy down that first. So on the yellow part, is there a grouping symbol? No. Is there an exponent or radical? Yes, we have this 5 squared. 5 times 5 is 25. So we get 10 plus 25 times 2. Alright, we're still only going to worry about the top until we have one number left on the top, or the numerator. Okay, so we keep the bottom. 10 plus 25 times 2. Is there a grouping symbol? No. Is there an exponent or radical? No. Is there multiplying or dividing? Yes, there is multiplying. So we have to do 10 plus what's 25 times 2, or 25 plus 25. That's like having 2 quarters, and 2 quarters is 50 cents. We get 50. Alright? Now, again, we don't have one number left on the top, so we're going to keep the bottom as absolute value of -6 times 2. Now we can deal with the top. There's only one operation left, so we don't really have to go through the order of operations when there's only one operation. 10 plus 50 is 60. Now that we finally have one number on this top part, right here, since now all we have is 60, we can finally focus on that bottom part. Alright, so if we go to the bottom, we have the absolute value of -6 times 2. Yep, there are absolute value signs, but there's an operation inside of it. Okay, so we want to do that operation inside first. So we get 60 over what's the absolute value of -6 times 2 is -12. Okay, what's the absolute value of -12? -12 is 12 spots away from 0. Okay, so 60 divided by 12, if you know this off the top of your hand, that's great. 60 is a great number because we can think about a clock. There's 60 minutes in a clock. If I divide 60 minutes out into 12 parts, here's 60 minutes, the whole thing, and if I go 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, how many minutes in between are those? Well, it's 5 minutes, so we get 5. Is our final answer. Alright, so we're going to go to the so what. In your so what our so what is go over GERMDAS. And even when I write GERMDAS, I'm going to put arrows in, because it's exponents and radicals from left to right, multiplying and dividing from left to right, and adding and subtracting from left to right. You're going to go over GERMDAS after every step. Just in case after you're figuring out a grouping symbol it changes or anything like that. Alright? Thank you.